Hello and welcome to the second module of session 4 of Supply Chain Management course. In the first module of this session, we had started discussing the single period inventory model, and we had used the NFL replica jersey example to demonstrate the numerical method of arriving at a solution. And the solution was how much quantity should Reebok order from its suppliers, which maximizes the total expected profits for that particular SKU. Now, we had, towards the end of that module, said that perhaps we could also look at a much simpler, shorter method for arriving at the solution, and this module, we are going to discuss that. To understand what we are talking about, what I've done is, you remember we had done a plot of the expected profits versus order quantity from the Excel worksheet in the last module. And the curve that we had got was a kind of a parabolic curve where the maximum profit corresponded to our value of Q star. So what we have done is we have replicated that curve covering a much longer range of order quantities, okay? And this is the curve that we are going to use to understand our approach, our analytical approach, and this approach will be called the marginal analysis, okay? So what is marginal analysis? Let us see. Let's consider two costs, okay? The first cost, CE, is called the unit excess cost, E standing for excess. And the unit excess cost is when we go excess over the demand, which means that the order quantity exceeds the demand. Correspondingly, we also have a C shortage or CS, unit shortage cost. Whenever we go short, short means we have fallen short of the total demand, which means that Q, order quantity Q, is less than the demand X. Remember, X is a random variable because the demand is uncertain in our case. Okay, so unit excess cost and unit shortage cost are the two costs that we use to move forward. Okay? Now here we are. Suppose our order quantity is here. You know, let's say this is our order quantity. This is our order quantity. And I am just discussing or deciding whether to order one more unit or not. Let's call this one more unit as the Qth unit. Okay, Q can be any unit. Okay, so I am saying let us consider that what happens if I order one more unit, the Qth unit. Okay, for that one unit, we are going to consider the marginal excess cost and the marginal shortage cost. Now, what is the marginal excess cost? The marginal excess cost is, it is the expected excess cost for that one excess unit. Okay. Now, what is the expected excess cost? It is the unit excess cost multiplied by the probability that the qth unit is indeed an excess over the demand, which means multiplied with the probability that Q is greater than X. Remember, we go excess only if the order quantity is greater than X or the demand. Okay? So very, very simply we are saying that the marginal excess cost for the qth unit, remember we are talking of only one unit, the qth unit, the marginal excess cost for that unit is the unit excess cost multiplied by the probability that the qth unit is excess, that the qth unit is more than the demand, which means that the total quantity Q is greater than the demand X. The marginal shortage cost on that qth unit, remember the qth unit can be either excess or short. It can be short as well. So the marginal shortage cost on the qth unit is the unit shortage cost again multiplied with a probability, and the probability this time is that the qth unit is indeed short, which means that Q is less than the demand. You go short because you are falling short of the total demand. Okay? So we are going to now talk of these two costs, the marginal excess cost of the qth unit and the marginal shortage cost of the qth unit, and we are going to compare the two marginal cost. Okay? So please understand that if the marginal excess cost is less than the marginal shortage cost, the marginal excess cost, so let me just draw this for us to understand. So let us say the marginal excess cost is this much and the marginal shortage cost, in fact I should draw this on the other side, and the marginal shortage cost is, let's say, this much. So this is my marginal shortage cost and this is my marginal excess cost. If this is the case, as you can see qualitatively here, marginal excess cost is less than the marginal shortage cost. And there are two possibilities. You can either go short or excess. What would you prefer? Would you prefer to go short and incur a much higher cost of the shortage, or would you prefer to go excess and incur a much smaller expected cost? The answer is very, very obvious in this case, that we will prefer to go excess and incur a much smaller expected cost than go short and incur a much higher expected cost of shortage. Okay? So if that is the case, if the marginal excess cost is less than the marginal shortage cost, what will we do? We will add the qth unit and then we will look at the q plus 1th unit. If again the marginal excess cost is less than the marginal shortage cost, we will add q plus 1th unit. We will add q plus 2th unit, q plus 3th unit, and keep on increasing our order quantity by 1 unit. And therefore, we are talking of this range. This is the range where the marginal expected shortage cost is going to be much greater than the marginal excess cost. And therefore, we will keep on increasing our order quantity. Now, let us understand this a little bit more. Let's consider a quantity, order quantity here. Suppose we are here, you know. Now what is the probability? What is the probability that the demand will be only this much? Please remember that our mean demand is somewhere here. Okay, our mean demand is 32,000 units, and therefore, what is the probability that the demand will be here? The probability is very small. Okay, so therefore, what is the probability of going short versus the probability of going excess? You know, if you add one more unit here, you are here, and you add one more unit here, are you likely to go excess? Unlikely. You are likely to fall short because the average demand is here, you know. So the probability of going excess by adding just one more unit here is much smaller than the probability of falling short. And remember, these are the probabilities we are talking about. Okay, so therefore our shortage cost probability is much higher than our excess cost probability, and therefore marginal excess cost is less than marginal shortage cost, and therefore we will keep on adding one unit until the two marginal costs become equal. Okay, and what is that? Where is that? That is at the top. That is the point where the marginal excess cost and the marginal shortage cost are equal to each other. You get one more unit than that, the reverse will happen. Your marginal excess cost will be more than the marginal shortage cost, and your entire profit will start falling. Okay, the only reason that the profit is rising is because your marginal excess cost is less than the marginal shortage cost. But the moment marginal excess cost exceeds marginal shortage cost, your entire profit will start falling. So, therefore, we are saying that our optimal order size is related to this equality of the two marginal costs, and we will use this equality to arrive at the next result. So let us equate the two. We are saying marginal excess cost is equal to marginal shortage cost. Marginal excess cost is CE. The unit, marginal excess cost is the unit excess cost multiplied by the probability of excess, equal to the unit shortage cost multiplied by the probability of being short. Okay, now this probability of Q greater than X can also be written as X less than Q. These two are the same. Q greater than X or X less than Q are the same. Here what we are saying is Q less than X can be written as 1 minus P X less than Q, because remember Q can be either less than X or greater than X. Okay, so the probability of Q being less than X is 1 minus probability of Q greater than X, which is nothing but X less than Q. Okay, so we have written the same thing, and if we, the right hand side becomes CS multiplied by minus CSP X less than Q, and the minus CSP X less than Q can be taken on this side, and we get P X less than Q and 1 P X less than Q coming from that side, combine, etc., etc. We get probability X less than equal to Q star is equal to CS upon CS plus CE, and this ratio is important. It is called the critical ratio. You might ask, so what? We will understand the answer to that as we further discuss, but I want to emphasize here that calculating the critical ratio is very easy, because we know the unit shortage cost and the unit excess cost. So unit shortage cost divided by the sum of shortage and excess cost will give us the critical ratio. Okay. Now, let us understand the meaning of this. Let us understand the meaning of this result. The probability of x less than equal to q. What is the distribution of x? It is a normal distribution. Remember, our demand is normally distributed. What is the probability of x less than q star? Let us say our q star value is this. Remember, we are plotting q here or x here, the quantity here, okay? So let us say the q star value is here and x is varying from here to here. So what is the probability of x being less than equal to q star? It is the entire area which we have shaded as blue, as you can see in the figure. So what are we going to do? Very simple. We calculate the critical ratio. Okay? Use the critical ratio. What is the critical ratio? The critical ratio is probability of x less than equal to q. And what is that probability? The probability is nothing but the cumulative area under the normal curve. Okay? So the critical ratio gives me the cumulative probability. I go to the standard normal table, use this value of cumulative probability to find out the z value here. And once I have the z value, my q star can simply be written as mu d. Okay, mu d is the mean demand plus the z multiplied by the sigma d. Okay, remember mu d and sigma d are already known. Okay, the only thing I need is z. And where do I get the z from? I get the z value from the standard normal table. What value of probability do I look for? The cumulative probability that I look for is given by the critical ratio. So if you really see the analytical method, although we took some time to kind of discuss and derive it, at the end of it is very, very simple. Okay? How simple is it? Let us use our example of NFL replica jerseys to understand how we use this method. So here we are, once again with the same data. The unit selling price, P, is $24 per jersey. The unit buying cost for Reebok is $10.9 per jersey. The demand is normally distributed with a mean of 32,000. Oh, I'm sorry. Please read this as 11,000. Let me just correct it right now so that we don't leave it for posterior. I'll add a 1 here. Good. Yeah, I'm sorry for that. It was a it was a slip. So the demand is normally distributed with a mean of 32,000 and a sigma of 11,000. Okay, so now we are going to calculate the critical ratio or the unit shortage and excess cost. What is shortage cost? How do we find out the shortage cost? What happens when we are short? We are short, we lose something. What do we lose? We lose the margin that we could have made if we had not fallen short. And what is the margin that we lose? The margin that we lose is the price minus the cost, or $13.1 per jersey that we fall short. I hope that is very, very simple to understand. Whenever we fall short, in this case, in this example, the shortage cost, unit shortage cost, is going to be the profit margin that we stand to lose, which we could have earned if we had not fallen short. What is the unit excess cost? If we go excess, what do we lose? Well, we are not able to sell, whatever excess units we are left with, but we have spent money buying, those units. How much money have we spent in buying? Well, we have spent the cost, which is $10.9 in this case, and that $10.9 per jersey becomes our unit shortage cost. Very, very simple. We use these two to calculate our critical ratio. So that is 13.1. Okay, so the difference here is 13.1 divided by 13.1 plus 10.9. That gives us 24. So we get a critical ratio of 0.5458. I hope you are with me till now. It has been, it's quite simple actually, if you look at it. Okay, what do we do with this critical ratio? What is this critical ratio? This critical ratio, I said, so let us look at the normal distribution of the demand. Okay, the critical ratio is 0.545 or 546 or so. Now please note that the area till this point is 0.5, and therefore 0.54 would be this area, the total area. Okay, so let us say this area is 0.5458 or so. Let me just check the value again, 0.5458. Yeah, so that is 0.5458. Okay, so I want to find out what is the Z value corresponding to 0.5458. I have a copy of the normal table here. Now please note that this normal table gives me Z values starting from 0, which means that 0.5 of the area has already been covered. So how much area do I look for? So I look for an area of 0.5458 minus 0.5, which is 0.0458. I hope that is clear. Okay, so 0.046, let's say. So here we are, 0.04. Oh, I'm so sorry. Yeah, so 0.046. So these are our areas here. Where is 0.046? 0.044 is here, and 0.047 is here. So 0.046 would be somewhere around 0.01 and 0.02. So I take it as so here we are. So this is 0.1 plus 0.1. Okay, so I take it as 0.11. Okay, so my Z value for this comes out to be 0.11, and I multiply that Z value with the standard deviation, add it to the mean demand to get my order quantity, and we get an order quantity of 33,210 units, which is fairly close to the earlier value that we had got of 34,000. Of course, we could have fine-tuned our earlier value by taking the Q. We had taken Qs to be 1,000 units apart from each other. If we had taken the Qs, much closer to each other, we might have got a value much closer to this analytical value of 33,210 units. Well, that's that. We use a very, very simple method, much simpler, which takes much less time as compared to the numerical method that we had seen earlier in the previous module. So fairly simple. Okay, so just to summarize, how do we calculate or determine our order quantity? Very simple. We use our unit price and cost data to calculate the excess cost and shortage cost. We use the excess cost and shortage cost to calculate the critical ratio. And then the critical ratio gives me the cumulative area under the normal curve. We find out the Z value from that, okay, from the standard normal table, and then Q star is simply mean demand plus Z times the standard deviation of the demand. Okay, now one final bit to be added to whatever we have just learned. We are going to consider a couple of other costs in addition to the costs that we have already seen. The first is what we call the salvage value, which we are considering or taking it symbolically as G dollar per unit. Now what is salvage? Salvage is when you go excess. You go excess means the order quantity has exceeded the demand. You are left with some inventory at the end. Earlier, we were disposing of this inventory at zero cost or zero return. Now suppose we are able to sell off this inventory, the excess inventory, not at the original price P, but we are still able to sell it off for some very small price, which is called the salvage value. This we are taking as G dollar per unit. So that is one input that we consider additionally. The second one is that we are saying that maybe there is an additional penalty for falling short. You know, when you fall short, you are of course losing the margin that you could have made, but maybe you are losing something more than the margin, notionally at least. Let us understand this. Suppose I am selling something, I don't know what, let's say I am a tea vendor, I am a tea stall selling piping hot tea of say different kinds. Now, one customer comes and asks for a certain kind of tea. Unfortunately, I have already exhausted the stock of that tea. And therefore, what is happening? I am falling short of the demand. The customer walks away. I don't make any money I could have made if I had not fallen short. So I lose the margin. But if the customer had the tea from me, the customer could have purchased some biscuits, the customer could have purchased some samosa or some pakodi, I don't know what, there are many other things that I sell. So I lose the margins on those as well. Are you able to understand this? So I am not only losing the margin on the product that I fall short on, I also lose certain other margins which the customer could have purchased if I had not fallen short on this product. And therefore, I am saying, let us call that penalty, an additional penalty for falling short, and we are naming that as B dollar per unit. Okay? So, what will happen? Well, our excess and shortage costs will now change. How will they change? The excess cost, where I go excess, earlier was only C. I was losing the money I had spent in buying one unit. But now I am not losing C because I am able to sell that one unit for G, which is the salvage value. So how much am I losing? I am actually losing C minus G per unit. And therefore, my excess cost, unit excess cost, is C minus G dollar per unit. Let's come to the shortage cost. If I fell short, I was losing P minus C, the margin. Okay, but now I am also losing an additional amount B. So this is P minus C plus B dollar per unit. Okay, so we are just modifying our situation, adding certain elements which are more realistically possible in a real life situation. Okay, now if that is the case, let's extend our NFL replica jersey example. All the costs and prices, everything remain the same. Okay, our demand remains the same. The only thing that we are saying is, maybe, you know, Benetton at the end of the NFL season is left with some excess jerseys, and instead of, you know, throwing them away at zero return, is able to perhaps sell them, I don't know to which market, but to some segment of the market at a much reduced value of $7 per jersey. So that becomes our salvage value. What does this change? Does it change our shortage cost, or does it change our excess cost? Our shortage cost, which was the margin that we were losing earlier, still remains the same. Okay, if we go short, we lose the margin. And how much margin is that? That is $13.1 per jersey. But what has happened to our excess cost? Our excess cost earlier was 10.9, but now it is 10.9 minus 7, because we are able to recover $7 for every unit that is excess, and which is $3.9 per jersey. And therefore, our critical ratio now has changed. We use the new numbers, and we find that the critical ratio has increased 0.77 instead of 0.54 earlier. Okay? Now, critical ratio increase means what? In the same normal curve, this was 0.54. 0.77 obviously will be somewhere to the right, so that the area till this value is now 0.77. I need to find out what is the Z value corresponding to 0.77, and from there I find that my Z value is 0.74. If you consult your standard normal tables, I'm sure you will be able to verify that. And therefore, what is my Q star? Well, my Q star is mean demand plus Z value multiplied by the standard deviation. Now it is 40,140 units. So everything remains the same. The method remains the same. The only thing that changes is our estimation of the unit shortage or the unit excess cost. Thank you very much. That brings us to the end of this module as well. All the videos as well as the PPTs are there uploaded for you. You can refer to those. If you have any doubts, queries, questions, views, points, thoughts, please don't forget to use the online discussion forum, and please raise those queries inside the classroom as well. Goodbye.